Good morning, friends. This is series of lecture for T.Y.B.Sc Analytical Chemistry semester 6 student, and the course is CH611A. Here the chapter we are going to study is chapter number 6, flame emission spectroscopy. Now in this chapter we have already learned about the introduction principle of the flame emission spectrophotometry or spectroscopy or flame photometry, type of the burner, that is a premix burner, laminar flow burner, along with instrumentation involved in the flame emission spectroscopy. In that instrumentation, the flame, what type of flame is used, what type of burner is used, which type of wavelength isolation system is employed in the flame emission spectroscopy. Now the next part of the instrumentation involved in the flame photometry is the detector. Detector is an important part of the instrumentation, that is a flame of the chapter, that is flame emission spectroscopy. Now detector is nothing but it is a device which is employed to detect the signal obtained from the wavelength isolation system. So let us see one by one step involved in the detector. The first point, the radiation coming from the optical system. This optical system is nothing but the wavelength isolation system, and this wavelength isolation system is the it is consist of entrance slit, monochromatic system, and the exit slit. Now the radiation coming from this optical system is allowed to fall on the detector. Detector is used to measure the intensity of transmitted radiation falling on its surface. Now here, on that detector, radiation are bombarded, which this radiation have the passage from the optical system, and that through the optical system the radiation strikes the surface of detector. Now the detector is used to measure the intensity of transmitted radiation falling on its surface. Whatever the radiation coming from the optical system, they strike the surface of the detector, where the intensity of transmitted radiation is measured. The third point is that detector should be sensitive to radiation of all wavelength under examination. So detector is sensitive to all type of the wavelength under examination. Now we know the range of the wavelength is many much more. Now here the wavelength which is under examination from the which passed through the monochromatic system, that radiation, the radiation has a particular wavelength, and this wavelength has to be measured by the detector, and all type of the wavelength is measured by the detector. The fourth point, in flame photometry, here the most essential point is that in flame photometry, photomultiplier tube is used as a detector. Now here photomultiplier tube is the detector employed in the flame photometry. Now here we know that photomultiplier tube is also used in UV visible spectroscopy, because it is essential in UV and visible light. The function of the photomultiplier tube is to convert light signal into electrical signal. So light signal is converted into electrical signal by the photomultiplier tube, which acts as a detector in flame photometry. Hence, a light of certain wavelength falls on the detector, electrical signal is produced. So here electrical signal is produced by the virtue of a detector, because detector detects the signals, and this electrical signal is the result of conversion of light into electricity or electrical part. Now whatever the electrical signal is produced, they get measured. Readout device of the readout, this point is there. readout device of flame photometer is a simple device where an electrical signals from the photomultiplier tube are converted into meter or digital signal. So here, after that conversion of electrical signal, there is a measurement system. That measurement system is called as a readout device. So readout device is a simple device where electrical signals from the photomultiplier tube are converted into meter or digital signals. So digital signals are very important for the characterization of the intensity as well as the wavelength. So here, readout device is a device where electrical signals from the photomultiplier tube are converted into digital signal. So this is a typical diagram for the photomultiplier tube. Now in this photomultiplier tube, we will see this photomultiplier tube in next lecture, because there is a we will focus on this construction, working and application of the photomultiplier tube in next lecture. So this lecture is nothing but the identification, or you can say identity of the detector, used as a important part in the instrumentation of flame photometry or flame emission spectroscopy. So these are the some points regarding about the detector. One important point, that photomultiplier tube is used as a detector. It converts the light signal into electrical signal, and this electrical signal will be get converted into particular digital signal from the readout device. So this is important point you have to remember. With this content, I conclude this lecture. Thank you very much for your patience listening.